Let's try a little thought experiment. Imagine you're lost in the endless, pitch-black waters of the Southern Ocean, right off the coast of Antarctica. If you make the mistake of looking down into the freezing abyss beneath your feet, you'd probably expect to see nothing but tiny fish or faint clouds of microscopic plankton. But what's actually lurking down there is far more terrifying. Nightmarish spiders with leg spans wider than a full-grown dog are crawling across the seafloor. Ghostly jellyfish slowly drift by, trailing venomous tentacles longer than the biggest blue whale. Even the most normal-looking fish down here look like massive, mutated freaks. And yes, every single one of these creatures is absolutely real. The freezing, extreme cold of this environment has let evolution go completely off the rails. Welcome to the world of polar gigantism, a biological phenomenon that most people on Earth don't even know exists, simply because it only happens in the coldest, most unforgiving oceans on the planet. Common sense tells us that in a place where everything is literally freezing and food is critically scarce, animals should get smaller and smaller just to conserve precious energy. But here, the exact opposite happens. Every animal in this region turns into a supersized variant of itself. Small creatures become big, and big creatures become colossal. But why does this effect even happen in the first place? To truly understand polar gigantism, let's take a look at the most blatant example of it, the colossal squid. And I know what you're thinking. Most people assume the colossal squid is just another case of deep-sea gigantism, but it's actually not. Colossal squids live almost exclusively in the oceans surrounding Antarctica, swimming in waters close to or even below freezing, around 32 degrees Fahrenheit. Because of the extreme salinity, the water doesn't actually freeze at this temperature, but regardless, it is insanely cold, and so the squids had to adapt. Not many people know this, but from an evolutionary standpoint, colossal squids are actually a type of glass squid. This family gets its name from a group of completely translucent creatures that look exactly like living, breathing glass. So why do colossal squids look like anything but clear glass? This is exactly where polar gigantism comes into play. In an environment this extremely cold, being see-through is simply a disadvantage. The colossal squid traded its invisibility for thick, heavy flesh, the perfect insulator against the deadly freezing temperatures. But it didn't give up on stealth either. Instead, its body took on a deep, blood-red color. And here's a shocking fact. At these extreme depths, red pigment doesn't reflect light. It actively absorbs any faint glow coming from bioluminescent prey, which means its victims will never see this massive monster coming. When you're this big, you basically have no natural predators, except for the occasional sperm whale crazy enough to risk a fight. Because of this, the squid's entire body is engineered for sneaking up on prey, not for running away. But that still doesn't answer the biggest question. Why did colossal squids get so incredibly huge in the first place? And the answer isn't found in the amount of food on the seafloor. It's in the water itself. Freezing water holds vastly more oxygen than warm water, and for basically all animals, the rule is simple. The larger the body, the more oxygen its cells need just to stay alive. In warmer oceans, there simply isn't enough oxygen to support the biology of supersized creatures. But when you live at literal freezing temperatures, oxygen is practically unlimited. The biological size limiter is completely broken. Over millions of years, this massive excess of oxygen transformed ordinary tiny glass squids into giants, or more accurately, into colossals. And since larger bodies are much better at storing heat and energy in this extreme environment, evolution literally gave these squids an ultimatum: become gigantic or die. But hold on a second. Giant squids, the ones people always confuse with colossal squids, don't live in polar oceans. So how did they get so big? That's where the effect of deep-sea gigantism comes in. But colossal squids took things a step further. They actually live even deeper than giant squids. Because of this, they represent an incredibly rare case of double crossover gigantism, combining both polar and deep-sea gigantism to create one truly magnificent monster. That's exactly why colossal squids are the heaviest invertebrates on Earth. Weighing in at over 1,000 pounds, they are literally twice as heavy as a normal giant squid. And their eyes? They're the size of a soccer ball, officially the largest eyes in the entire animal kingdom. But the squid is just one example. It alone doesn't prove that cold water is what creates giants. So take a look at this guy. This is a normal sea spider, the kind you'd find crawling around a warm coral reef. Technically, they aren't real spiders. They're called pycnogonids, but that's beside the point. These little guys usually measure about ½ an inch across. That's roughly the same size as a normal house spider you'd see running up your wall. But find this exact same animal in the freezing Antarctic Ocean, and it looks like this. This absolute monster has a leg span of over 2 feet, and it belongs to the exact same family as that tiny reef spider. So what on earth is going on here? The exact same rules that turned fragile glass squids into colossal giants forced these spiders to grow. Freezing cold water means a massive abundance of oxygen. And here's where the anatomy gets genuinely horrifying. These spiders literally breathe through their legs. You can already see just how freakishly long those limbs are, constantly pulling in massive amounts of oxygen. Because their central body is so impossibly tiny, they completely ran out of room. So nature literally shoved their intestines and even their reproductive organs straight into those giant spindly legs. But what do they actually do with all that size? Unlike crabs or lobsters, giant sea spiders aren't brawlers. But make no mistake, they are ruthless predators. They creep eerily across the sea floor on those massive legs, using them almost like giant stilts to casually step right over sponges, corals, and starfish. Then they strike. They plunge their long, needle-like proboscis straight into their prey like a starfish and just suck out its insides, exactly like a gruesome milkshake through a straw. Speaking of starfish, we are in the Antarctic Ocean after all, so the local starfish are also incomprehensibly massive. I know what you're thinking, that barely even looks like a starfish, but it is a real starfish. It just has over 50 arms instead of the normal 5. Antarctic starfish are on a completely different level of freaky. They didn't just grow larger. Evolution literally started stacking on as many arms as it felt like. Most normal starfish are predators too, and will usually eat things like clams. But Antarctic starfish are so brutal, they will literally eat other starfish. The rule down here is simple. Whoever has the most arms wins. Plus, they can live for over 40 years on average, which absolutely crushes the 5-year lifespan of your typical warm water starfish. And yes, this is polar gigantism at play once again, forcing these otherwise cute, harmless creatures to develop into multi-armed, gigantic freaks. Funnily enough, the effect of polar gigantism is so incredibly powerful that it actually created the longest animal on the entire planet, the lion's mane jellyfish. If you compare the length of its tentacles to a blue whale, you'll see that this jellyfish is noticeably longer. Sure, the whale has way more mass, but this just goes to show the sheer scale of what extreme cold can do. By spreading out its tentacles, this jellyfish creates a deadly stinging net the size of 2 full basketball courts. If you compare it to a jellyfish from the exact same genus, like the blue jellyfish from warm waters, the difference is absolutely staggering. Warm waters simply never forced the blue jellyfish to become massive. After seeing all these overgrown monsters of the abyss, you're probably wondering, is high oxygen really the only thing that allowed them to get this huge? Well, oxygen is a massive part of the reason, but it's not the full answer. Because the water is so unimaginably cold, animal metabolisms slow down to an absolute crawl. And they slow down so much that having a massive body actually becomes incredibly efficient. They burn way less energy per pound of raw body mass. On top of all that, the freezing ocean is actually a surprisingly stable environment. I know that sounds weird after showing you a bunch of giant, terrifying monsters, but the water temperature down here practically hasn't changed in millions of years. The pressure is constant, and predators are extremely rare. There is absolutely nothing forcing these animals to stay small and fast. They can easily afford to be massive, slow, and built like absolute tanks, which is exactly the survival strategy the colossal squid developed. But that brings up a very logical question. If the cold makes everything bigger, does that mean a polar bear is a case of polar gigantism? I mean, they are way bigger than normal brown bears. Or what about emperor penguins? They absolutely dwarf normal birds. Here's the catch. Polar gigantism only works for cold-blooded animals, creatures that let the environment control their body temperature and extract their oxygen directly from the water. For them, freezing water means more oxygen, a massively slowed down metabolism, and exactly zero energy wasted on generating body heat. But warm-blooded animals are stuck with a completely different problem. They have to constantly burn energy just to stay alive and keep warm, no matter how freezing the air or water gets. The bigger they get, the more calories they need. And in the barren polar regions, there simply isn't enough food to support something truly massive. Every extra pound of body weight comes with a huge metabolic cost. So why are bears and penguins still so huge then? It all comes down to something called Bergmann's rule. This rule states that in freezing climates, warm-blooded animals do actually get bigger, but not because of oxygen. It's because larger bodies lose heat much slower. That's exactly why polar bears are so massive and why emperor penguins look like absolute giants compared to normal tropical birds. That extra body mass helps them hold on to their body heat for much longer. It works just like built-in insulation. It's the exact same reason why woolly mammoths grew to be so enormous. But for warm-blooded creatures, there is always a hard limit. If you get too big, you will literally just starve to death in the frozen wasteland. And that is why Bergmann's rule will never allow a warm-blooded animal to go full colossal squid mode. But let's dive back into the water, because even in the microscopic world, gigantism takes over. Antarctic copepods are basically the polar supersoldier version of normal plankton. They are nearly 10 times heavier than their tropical cousins. For context, most copepods are so incredibly tiny that you can't even see them without a microscope. They're usually less than a millimeter long. But Antarctic copepods can reach nearly half an inch. They are so massive, you can actually watch them swimming with your bare eyes. Sure, they aren't terrifying monsters to us, but in the eyes of other plankton, they are absolute leviathans. But here is the strangest part of all this. Not everything in the polar oceans got the gigantism upgrade. A select few animals got the exact opposite effect: polar dwarfism. Yes, it's extremely rare, but certain Antarctic species like icefish and sea snails are noticeably smaller than their relatives in warmer waters. Why? Because in these extreme conditions, food isn't available year-round. So evolution gave them smaller bodies so they can reach adulthood faster, reproduce sooner, and survive much longer periods of starvation. When food is only around for a couple of months a year, staying small is literally the difference between life and death. And by the way, the blood of an icefish is completely transparent. They have 0 red blood cells, but they are absolutely packed with antifreeze proteins. They breathe simply by absorbing the massive amounts of oxygen in the water directly through their skin. It might not be as epic as turning into a giant kraken, but it is an absolute stroke of evolutionary genius. But the creepiest side effect of the cold is that it doesn't just change what evolves, it changes how fast it happens. In the polar ocean, everything runs in slow motion. Chemical reactions slow down right alongside metabolism and reproduction. It can take decades for a single generation of Antarctic animals just to grow up. Evolution already takes millions of years, but down here, it stretches into an eternity. Many of these species are essentially living fossils. They are nearly identical to their ancestors that swam beneath the ice tens of millions of years ago. Some lineages of sea spiders, urchins, and fish have barely changed since before humans even existed. With no drastic seasons, species in the Antarctic have stayed literally frozen in time. The environment barely changes, so evolution never needed to bother changing either. Every single creature here is perfectly tuned for a stable, predictable, and freezing world. And this system worked flawlessly for millions of years. Until today.
It is exactly this million-year stability that makes the Antarctic so incredibly fragile. When your entire ecosystem depends on absolutely everything staying exactly the same, even the tiniest shift can break it. The moment the environment starts to change, the very rules that built these giants begin to collapse. Being a super mega frost monster sounds awesome, until things suddenly don't go according to plan. Polar giants have one massive critical weakness. They are entirely built for stability, not change. Their very existence depends on freezing, dense water packed to the brim with oxygen. Take that away, and the whole system shatters. Warmer water holds less oxygen. As soon as the water warms up, animal metabolisms speed up, and suddenly, those massive bodies become their greatest curse. The animals that once ruled the frozen deep literally start suffocating, trapped inside their own gigantic size. If you take any of these monsters and drop them into a fun, warm, tropical ocean, they will literally cook from the inside out and die from suffocation under the bright sun. And unfortunately, this is already happening. As the world's oceans warm up, oxygen levels are dropping fast. The creatures that evolved to thrive in the extreme cold are simply running out of room to survive. Scientific studies are already proving it. The maximum sizes of sea spiders are actually shrinking in areas where the water is getting even slightly warmer. And while it's incredibly hard to study them, scientists fear that eventually colossal squids could become, well, not so colossal, or they might just die out altogether. And while I would definitely never want to come face to face with one of these deep-sea demons in the dark, it's honestly a little sad to think about them disappearing. These creatures are living relics from a completely different world. Plus, they are basically zero threat to us anyway. Throughout all of human history, the total number of people killed by a colossal squid is exactly 0. Nobody has ever been attacked by one. Whatever happens, the effect that extreme cold has on evolution is perhaps one of the strangest and most unexpected reasons for gigantism on our planet. Freeze the ocean and life won't die. It just becomes giant.